Hi everybody, I hope this video finds you well. In today's video, we're going to be wrapping up our discussion of correlation and regression by looking at one other sort of little tangent from seeing how to use the correlation coefficient in a different situation. So far, in the sort of main flow of our discussion of correlation and regression, we've been primarily using the correlation coefficient to establish a relationship between two quantitative variables with the hopes of modeling this relationship. In other words, in sort of the main flow of our analysis of correlation and regression, we use the correlation coefficient to establish that two variables were related, and then we perform that regression analysis to actually build a model for that relationship. However, while this is a very common use of the correlation coefficient, in other words, it is very, very common to use the correlation coefficient to establish if two variables are related, it turns out the correlation coefficient can be used in other situations. So we're going to see a way of sort of using the correlation coefficient, not in terms of trying to build a model, but just in terms of trying to measure agreement. So in other words, we're going to investigate how the correlation coefficient can be used to measure agreement. And what we mean by agreement is generally like for people, say, rating or reviewing things, do they really show agreement in how they view the different things that they're reviewing or rating? So to do this, let's go ahead and take a look at an example. So for this example, we're going to suppose that there's 4 film critics. So we have Amy, Barry, Cindy, and Dak. Each of these 4 critics watch the same 8 movies and give each movie a rating on the scale of 1 to 100. And the scores are below. So we've got our movies here, movie 1, 2, 3, 4, 5, 6, 7, and 8. And then here's the scores that Amy gave to each of those movies. Here's the scores that Barry gave to each of those movies, so on and so forth. So we're going to do, we got a lot of data here because we've got 4 different critics and 8 different films. So we have 32 different data points from all this sort of stuff. We're going to do a couple things of sort of really review-oriented things in A and B. We're going to talk about ordering the film critics from the highest to lowest average score. That'll sort of help us understand were some of the reviewers generally just giving higher scores than the others, and were some of them harsher than the other ones, were some of them giving really low scores, etc. So we'll try to understand the average that each reviewer gave, and then we'll also go ahead and order the film critics from most to least consistent. We should be able to do that using the standard deviation, which is our measure of variability, so we can see where some of the reviewers, really opinionated, meaning they were giving really high scores and really low scores, or were some of them pretty, sort of moderate and just gave everything pretty similar scores. So we'll understand that in B, and then we'll actually get to how the correlation coefficient can be used, and we'll try to figure out which pair of critics were most in agreement with their ratings on these 8 movies. And as you can imagine, that's going to be a little bit more challenging than just simply saying that they have similar scores, because we'll have to sort of do that from the perspective of what is their typical or average score, how much deviation did they do. I mean, you can sort of imagine one person saying that a movie was a 95 in their opinion. Is that really very different from somebody saying that it was a 75 in their opinion? Well, if the person who gave it a 75 pretty much never gives anything above 75, well, then a 75 would be really good as a score for them. So there's a lot to sort of consider to do this part C here, and it turns out the correlation coefficient takes care of all of that for us. But let's first get this data into our calculator, into some lists, so that we can do these calculations. So we'll keep it easy. We'll put Amy into L1, all of Barry's data into L2, Cindy into L3, and Dak into L4. So we'll get all 4 reviewers into their own lists. What we'll then go ahead and do is we'll also add onto the bottom of this table here, we'll add a little row for their average and for their standard deviation. So let's go ahead and get this data in. So if you're following along on your calculator, go ahead and put all of Amy's scores into L1, so 91, 95, 96, 71, 68, 55, 62, 97. In L2, all of Barry's reviews, so 70, 76, 73, 82, 85, 86, 87, 65. In L3, all of Cindy's ratings, 72, 74, 80, 32, 40, 35, 46, 75. And then finally, in L4, all of Dak's ratings, 93, 68, 97, 62, 93, 60, 99, and 62. Okay. Now, to get this average, we'll go ahead and use our one var stat, what we did much earlier in our course. So we'll hit stat, calc, and one var stats. We'll put L1 and get Amy's information first. We'll go ahead and record both things. So it looks like her average rating was a 79.4 with a standard deviation of 17.2. And of course, I'm going to use the sample standard deviation because we can probably assume they've watched plenty more movies. This is not every movie they've looked at. We'll go ahead and use the sample standard deviation. All right, then we'll hit stat, calc, one var stats, and use L2 to get all of Barry's information. Notice his average was 78 and a standard deviation of 8.2. For Cindy, we'll go stat, calc, one var stats, but we'll do it for L3. Looks like her average was 56.8 and her standard deviation was 20.3. And then finally for DAC, we'll do stat, calc, one var stats, and at L4. And looks like we should get 79.3 and a standard deviation of 17.6. All right, so if we were going to order the critics from highest to lowest average score, well, it would be Amy just barely in first with 79.4. Then Dak was 79.3 right behind. Barry with 78, and then way far down would be Cindy. So what we're basically seeing here is in terms of average, right? Amy, Barry, and Dak all basically gave average scores in the high 70s, but Cindy was a much harsher reviewer. Her average score was only 56.8. Now, of course, what that means is that some of these scores, like that 75 or that 80 for Cindy, when we get to Part C, we should keep in mind that that 80 and that 75, those are really good scores for Cindy, because again, her average is only 56.8. Her saying that a movie deserved an 80 or a 75 is actually a very strong recommendation, and given the very low average overall for her. Okay, let's go ahead and order also the film critics from most to least consistent in their ratings. Remember, most consistent would mean lowest standard deviation. So we can see that Barry was the most consistent with a standard deviation of only 8.2. Then Amy, then Dak, and then finally Cindy had the most variation. So not only was Cindy sort of the lowest average, she also showed the most variation, the least consistency, and that should sort of make sense. Notice she had scores as low 30s, 32 and 35, all the way up to the 80s, whereas somebody like Amy was sort of 50s to 90s. Barry was only 65 all the way up to 87, it looks like. So it makes sense that Barry showed very little sort of deviation, was the most consistent. Okay, so we've got those pieces there. All right, now let's go ahead and try to figure out which pair of film critics were most in agreement. And to do this, we're going to calculate the correlation coefficients. Remember, correlation coefficients are for two variables. So we have to do this pair by pair. In other words, we're going to take every pair of reviewers and see what their correlation coefficient looks like. So let's go ahead and start by doing, we'll start with Amy and Barry. So we're going to do our ln reg ax plus b, and we'll do it with L1 and L2. So we'll see what the correlation for Amy and Barry's ratings. So if we do that, and we do stat, calc, that ln reg ax plus b, we'll have L1 and L2. If we go ahead and do that, we should get an R here that's approximately negative 0.91. Okay, so first thing we should notice here is we got a negative correlation between these two, and it's a pretty strong negative correlation. So remember what a negative correlation means. It means that as one of the variables gets larger, the other variable gets smaller. In other words, as Amy's ratings go up, Barry's ratings go down. That would actually indicate that Amy and Barry have very strong disagreement or very dissimilar tastes. Let's see if we can actually see that in the data. Notice that some of the movies that Amy thought was best, movies like movie 1, 2, 3, and 8, Notice those are all 90 scores, and her average was 79.4, so 90s are certainly good scores, are also the ones that Barry gave lower scores to. Now, of course, his low scores were the 70s and that 65, but of course, those 70s and those 65, they are lower than the average of 78. And you might say, well, they're not that much lower. 76, 73, they're not that much lower than 78. But remember, he didn't show a lot of deviation. So only being a little under his average is still significant. So in other words, the movies that Amy really liked were also the ones that Barry disliked. Notice that's also the true for the ones that Amy did not like. Amy gave all of these low scores, 70, 68, 55, 62. These were all the ones that Barry liked the most, 82, 85, 86, 87, all above his average. And again, without very much deviation, being only a little above average is actually pretty significant for him. So what we can see here is that Amy and Barry actually show strong disagreement. In other words, for whatever reason, based on their tastes or whatever they look for in films, what Amy is going to say is a good film, Barry is not going to like as much, and whatever Barry says is going to be a good film, Amy's not going to like as much. In other words, they disagree about how to analyze these things. All right, let's try another pairing. Let's go ahead and see what happens if we take Amy and Cindy. So we'll use our linreg ax plus b. This time we'll do L1 and L3, since Amy was in L1 and Cindy was in L3. So we can do stack calc that linreg ax plus b. We'll go ahead and put in L1 and L3. We'll calculate that, and we should get an R that comes out as about 0.93. Now that would be viewed as strong agreement. In other words, Amy and Cindy seem to be on the same page. Now, you might look at the data and say, that doesn't seem to make sense, right? I mean, movies 1 through 3, Amy was giving 90s, whereas Cindy gave them low 70s and an 80. But of course, we got to think again about what is their typical score. These 90s are significantly above the average, meaning these are films that Amy really liked. Remember, Cindy's average is only 56.8, so those 70s, that 80 and that 75, those indicate films she also really liked relative to her lower average. So that really shows that the films that Amy liked, those first three and the last, are also the ones that Cindy liked. Notice the same thing for the ones they disliked. These were the ones that Amy generally gave lower scores, and Cindy gave them incredibly low scores, which of course makes sense because she generally gives low scores overall. So these two were in strong agreement. They seem to really agree. They don't give the same scores, but they agree relative to each other that movies like 1, 2, 3, and 8 are the good ones of this batch, where 4, 5, 6, 7 are sort of the bad ones of this batch. Okay, now that doesn't necessarily mean that they agree the most. We've got many other pairings to do. Let's go ahead and see about Amy and Dak. So now we're going to do L1 and L4. So we'll go ahead, use the same approach, lin reg ax plus b. We'll do L1 and L4. So let's go ahead and do that, lin reg ax plus b, L1 and L4. And what we get here is 0.04. Now, what does this mean? Well, it's not a strong negative, it's not a strong disagreement, it's not a strong positive, it's not a strong agreement. It really just seems to be sort of neutral, right? This means no disagreement / agreement. Okay, now that might be a little bit strange when we think about people sort of reviewing things, but what that means is that they don't necessarily agree and they don't necessarily disagree. If we, again, remember, we sort of have identified that movies 1, 2, 3, and 8 were the ones that Amy really liked. What about for Dak? Well, he seemed to like movie 1, right? That was a 90, so he would agree with Amy on that. He liked movie 3, he would agree with Amy on that. But he also liked movie 5 and movie 7. Well, movie 5 and movie 7 were two of the ones that Amy really disliked. So they have some agreement, some disagreement. They really don't have a strong relation at all, either way. What that probably would indicate is that they might be using completely different metrics to sort of analyze this, where Dak is using things that is not even relevant to Amy, because he's picking out some things that he likes that Amy would agree with, but he's also picking out some things that he dislikes that Amy would disagree with. So they have no real agreement or disagreement between them. All right, if you think about it, those are all the pairings that involve Amy, right? We did Amy with Barry, Amy with Cindy, and Amy with Dak. But there are still some other pairings that we need to do. We need to consider Barry and Cindy. We need to consider Barry and Dak. And then finally, we need to consider Cindy and Dak. Okay, well, let's go ahead and do our next pairing then, which we can just continue on. We'll do Barry and Cindy. So we'll do our lin reg ax plus b. We should use L2 and L3. So if we do that, we do stack calc lin reg ax plus b, L2 for Barry, and we'll do L3 for Cindy, calculate, and we should get R is approximately negative 0.85. So we get strong disagreement again. Now, does that make sense? Does it make sense given what we found up here that Barry and Cindy should disagree with each other? Well, yeah, it should make sense, right? We knew from here that Amy and Barry disagreed, and we knew that Amy and Cindy agreed. So if you happen to agree with somebody who disagrees with somebody else, well, you would probably disagree with them as well. And that's exactly what we saw here. We saw that Amy and Cindy are sort of on the same page, and Amy and Barry are definitely not. So Barry and Cindy are also not on the same page. They've got strong disagreement. What do we expect for Barry and Dak? Well, if we think about it, Amy and Barry, as we know, are sort of opposite. Amy and Dak had nothing going on, so probably Barry and Dak also have nothing going on because Dak seems to be isolated, sort of off on his own here. So let's check that. Let's go ahead and do our lin reg ax plus b. We'll do L2 and L4. So we'll do that lin reg ax plus b, L2 comma L4, or if you have the newer calculator, just typing in L2 and L4 right as next to them there. And you should get R is approximately 0.10. Again, a little bit more, I guess, of an agreement than we had between Amy and Dak, but certainly still no real agreement. So no disagreement / agreement. All right, we've got one last pairing. The last pairing we have is Cindy and Dak, right? These two together. Notice we don't have to do pairings like Barry and Amy if we've already done Amy and Barry, because, of course, we're just talking about whether or not they agree or disagree, so it doesn't matter the order. So the last one we need to do, Cindy and Dak. So lin reg ax plus b, last one here, L3 comma L4. So we'll go ahead and do that, L3 and L4, and we'll calculate there, and we get approximately 0.21. Again, 0.21, a little bit stronger of an agreement, but still nothing that we would consider significant, so no disagreement / agreement. So what does this sort of tell us about these sort of four critics here? Well, it basically tells us that the way sort of Amy and Cindy think about these films are very similar, even though Cindy apparently is a much harsher reviewer, just gives lower scores overall, but they sort of agree, at least out of these 8 films, which ones are sort of the better of the 8 and which ones are the not so good. Amy and Cindy both strongly disagree with Barry. In other words, the ones that Amy and Cindy are picking out are the ones Barry dislikes, and the ones Barry is picking out as good films, Amy and Cindy dislike. Dak, on the other hand, the fourth person here, seems to be just sort of out on their own. They like some where they agree with Barry, some where they agree with the duo of Amy and Cindy, but they're not really agreeing or disagreeing strongly with either of the people. So why is this sort of useful? Well, you can imagine, different sort of applications of this. This can be used for understanding, like on different streaming websites and things like that, understanding people's like tastes and giving them recommendations. If you know that a certain person has rated titles, say, maybe Amy is a heavy user of something like Netflix or some other streaming service, and she's watched a bunch of things and has given them a bunch of recommendations. Well, after seeing that Cindy, maybe who hasn't used Netflix as much, has similar sort of views or likes things similarly to Amy, well, then other things that Amy recommends, you could then feed to Cindy to have her see things that she would also enjoy. So you can imagine that understanding sort of the agreement or sort of the taste that people have in things is a very sort of useful application of correlation here. Notice that here we didn't build any models. We weren't trying to make any predictions. We were just trying to understand whether or not people sort of agreed with each other, disagreed with each other, or really, sort of were off on their own, judging things in a completely different way, which is what we discovered with this fourth person here. All right, this wraps up our sort of last little piece that we wanted to discuss about correlation and regression. Again, this was an application entirely just of the correlation coefficient. We didn't do any regression there, but it does sort of finish up our investigation of working with pairs of quantitative variables. In our next video, we'll start our investigation of how to understand the relationship between a pair of categorical variables.